So here it is running. This is the 4th episode in my series of converting this Stirling engine to a steampunk style. So I'm using brass to replace the original parts, the pulley, the flywheel, and the bearing support, which is now here. This was the previous episode where I made this tombstone style bearing support. So now what I'm going to do is make a mount for this motor generator. This is a little 3-volt DC motor being used as a generator, and as you can see, it's powering and lighting this little LED. Eventually I'm going to mount several LEDs around the piece to self-light it. And I might even make some kind of acrylic cover for the whole thing. But in the meantime, obviously they used a very cheap fixture of some kind here, just a standard, maybe a conduit holder or something. So again, I'm going to go back to the tombstone concept here and make a little tombstone mount right here. This is almost exactly an inch, just under an inch diameter, so I'm going to be drilling a hole for an inch diameter for this little motor and bolting it probably through from the bottom and clamping it down. So stay with me and we're going to have an adventure making a little tombstone mount for the generator. I've got this chunk of 1/2 inch brass here that I've marked off for 1.5 inches square with a dead center hole, and then of course I'm going to round it over to make the tombstone shape. So first thing is to cut this out on the bandsaw and true it all up on the mill. I'm starting by cutting a square out of 1/2 inch brass stock. Eventually one edge of this will be rounded over to create the tombstone shape. So first I'm just going to mill all the edges to make a nice clean rectangle, or square in fact. Drilling a hole in the center. This 1/4 inch hole will be used to pin it down to my rotary table so that I can create the radius of the top edge of the tombstone. So here I'm using a bunch of washers to get it up above the rotary table, and I'm using a rubber washer on top there. And then this I'm going to bolt down and secure a little more tightly after that. And here we go. So very carefully turning the rotary table. Notice I'm tensioning that knob on the left occasionally because it's drifting loose and it needs to be secured. So I reduce the chatter. And there can be a little bit of chatter if the whole thing just jiggles back and forth a little bit. So yes, I came off a little off center, so I'm just going to clean up that edge. Easy enough to do. This is all low precision stuff, and you know, I can just wing it when I get to things like that. So now I've just got to recenter this on the mill. So I'm going to use my centering tool, center finder, drop it in there, and just drive the X and Y axes over it so I can maintain concentricity with that hole. So now I'm going to use my old Irwin step drill. In retrospect, could have chucked this up on my 4-jaw on the lathe and then bored it out, but I don't have a boring bar for my milling machine. And I've been using these step drills, yeah, of course, now it does get stuck every now and then, and that's the advantage of having a belt drive. I've been using these drill bits for 40 years or so, back before when they were still in patent and only one company, Irwin, was making them. They're really handy for cutting holes in materials, but not so great for doing deep work like this. So as you can see, it's stalling a little bit, but the advantage again of having a belt drive system is it'll just slip. So I'm going to link below to the motor drive and belt drive upgrade. I used the little machine shop belt drive and then adapted and upgraded it when I wanted to add the 600 watt 24 volt DC motor to drive the system here. You'll notice that the thing stops, the drill and the mill stops instantly when I stop it, because that's one of the features of the motor that I've added. So here I am flipping over the tombstone mount here, and then I can use the step drill itself to recenter it before I tighten it back down in the vise. These things are wonderful at self-centering into their original hole or any hole. So again, going very carefully, and no matter how carefully you go, you will get a stop, or I will. But I'm clearing all the way through now. I'm going to bottom all the way through, so I've gone through from both sides. This is the 1-inch maximum diameter step drill. So there we go. I've created a complete through 1-inch hole. It's looking pretty. So now just to test fit the motor, as I expected, it's got a lot of wiggle room in there, and I've got a solution for that. So now I'm just going to center find the base. I've got the whole thing in upside down because I need to put a couple of mounting screws that will go through the wood base and up into the bottom of this. So I'm going to drill and tap a couple of 832 holes. So I'm moving over from my center reference, doing my starting drill. These are exactly 1 inch apart, which is just a convenient dimension, especially for those of us who do a lot of woodworking. We don't do tenths and thousandths when we're woodworking. So this is the 832 tap drill. I'm going in about 500 thousandths, long enough to get a good penetration through the wood and into the brass to secure this to the wood base. In order to account for the fact that the motor is a little loose in here, I came up with a piece of brass strip that fits perfectly inside of here. So I'm going to just drop it in right there, putting the open part at the bottom. It force fits in rather vigorously. There we go. So that's stuffed in there now, and then this will stuff in there as well. But before I do that, I've got this gold marking pen, Sharpie, and I've already started marking it here. This is to make it look more steampunk again. That's the whole project here. So we'll shake this up a little bit and see if I can apply some around the outside here, because this will probably stick out. And then I'll do the whole back as well, because that will be very visible on the outside edge. This stuff is really amazing. It really looks like a brass, although technically they call it gold. And then I'm going to do the whole back here. Yeah, let's see if that works. Oh, looks like I got some on my pad here. Okay, I'm going to wait for that to dry, and then I'm going to drop that in there. Okay, so I seem to have got a good steampunk look on that motor slash generator. It's a cute little motor, and it generates enough power to run quite a few LEDs. Notice I also shortened the shaft here and made this pulley, which this is a sneak preview. I'm actually going to show you that shortly, how I made that pulley. So here we go. I'm going to jump right in. I'm going to start by making the V-groove for the pulley with a 30-degree carbide cutter. It drops in really nicely, and it's the right bevel angle for, this is actually a round pulley, but it would be perfect for a V pulley as well. Yep, there's the old pulley. Everything looks about right. The V looks the same depth. I was just eyeballing it. Maybe tweak it just a little bit. And just do a little bevel on the outside edge to clean it up. Check the shaft diameter, 5/64ths, so starting with a center drill and 5/64th drill bit. Yes, I did an undersized drill bit first, and then the 5/32 or 5/64 drill bit, just to make sure it's a precise hole. So I'm just checking the motor shaft right now, and yes, it does slide in there a little looser than I would have liked. I'm going to chamfer that edge with a chamfering bit. Drop in the parting tool and start parting, because parting is such sweet sorrow. Taking my time and using a drill bit here to catch the pulley when it falls off. Any second now. There she is. Isn't that pretty? So now I'm flipping it over, and I'm just going to polish it up with some Scotch-Brite. make it all ooh shiny. That's the whole point of this thing, to be brassy and shiny and steampunky. So now it does fit on the shaft, but it fits just a little bit loosely. Once it goes on, it'll actually slide a little bit. So I'm going to use some thread lock here, just a little dollop. It's always hard to get a small amount, so I have to keep kind of taking it off. That's still too much, so I'm going to wipe a little piece off with my finger there and slide that on very carefully, and that should hold just perfectly. So here it is running. I've got an LED powered by the generator that's belt drived over to the main shaft here, and of course the work that I finished here with the pulley hidden on the other side and the tombstone mount for the generator. These are the parts that I've removed. I'm mounting it to this aluminum base, the original base, just to have a placeholder, and eventually it'll all get mounted to the wooden base. So I hope you've enjoyed watching this, and if you have, please give me a like and subscribe so you can see the rest of the videos. So thanks for watching, and hope to see you soon.